Welcome dear students, myself Brushali Pagare, faculty of KK Polytechnic Nasik. Today we are going to see the topic of function. This is basically for the students of diploma. I will see some definitions which are required for the topic of function. First is a constant. A constant is a quantity that does not change, that does not vary. For example, pi, 2, 3, etc. Next, variable. It is the quantity that changes, that varies. It's called as a variable. Now, there are two types of variables, dependent variable and independent variable. The variable which depends on some other variable for its value is called as dependent variable, and the variable which is free to assign itself any value is called as independent variable. Look at the example. A is equal to pi r square. A is depending on r. Pi is a constant. As r will change, correspondingly A will also change. So A is called as the dependent variable, R is the independent variable, whereas pi is the constant. Now let us move on to the definition of function. Let A and B be two non-empty sets such that every element in the set A is mapped to one and only one element in the set B, then the mapping is called as a function. In this case, the set A is called as the domain and the set B is called codomain. Functions are generally denoted by lowercase letters f, g, h, etc. Now this is the figure. We have two non-empty sets, set A and set B. Set A contains the elements 1, 2, 3 and set B contains the elements A, B, C. F is a function mapping the elements of A to the elements of B. Now look, 1 from the set A is mapped to C in B, 2 is mapped to A, whereas 3 is mapped to B. Now look, all the elements in the set A are mapped 1, 2 and 3. No element is left out. And every element is mapped to one and only one element. Like 1 is mapped to only C and no other element. 2 is mapped to only A and no other element. Similarly, 3 is mapped to only B. So it satisfies the definition of function, that is, every element in the set A is mapped to one and only one element in the set B. Now 1 maps to C under the function f. So we say that f of 1 is equal to C. So C is called as the image of 1. Similarly, A is the image of 2 and B is the image of 3. That is, f of 2 is equal to A and f of 3 is equal to B. Have a look at this example. Here again we have two sets A and B. A contains the elements 1, 2, 3 and B contains the elements 2, 3, 4, 5. Now all the elements in the set A are mapped. 1 is mapped, 2 is mapped and 3 is mapped. 1 is mapped to 2, 2 is mapped to 3, but 3 is mapped to 4 and 5. That is two elements in the set B. Here the definition of function fails. What does the definition say? Every element in the set A should be mapped to one and only one element in the set B. So 3 is being mapped to two elements. That is, 3 has two images, so it is not a function. Now we will see function representation. First is the ordered pair, in which we can see there are pairs, and
And ordered means first element belongs to the set A and second element belongs to the set B. So 1 is mapped to 1, 2 is mapped to 4 and 3 is mapped to 9. This is indicated in the ordered pair. Next, we all know the Venn diagram. We'll have two sets A and B. A contains the elements 1 to 3 and B contains the elements 1, 4, 9. F is mapping from A to B and you can easily observe that 1 is mapped to 1, 2 is mapped to 4 and 3 is mapped to 9.
The next is the tabular form. It consists of a table which has two rows. One row is for x and the second row is for y. So first row contains the values of x 1, 2, 3 and the second row contains the values of y, that is 1, 4, 9. So we can observe here 1 is mapped to 1, 2 is mapped to 4 and 3 is mapped to 9. The next is the equation form. We can also represent a function by an equation. So let y equal to f of x, that is y is a function of x, that is y is equal to x square, where x takes the values from the set containing 1, 2 and 3. Now we'll see the types of functions. First is the algebraic function. It is a function that contains only algebraic operations like addition, subtraction, multiplication, division, as well as fractional or rational exponents. For example, y is equal to x cube plus x square plus x, or y is equal to x plus 1. Now, the logarithmic function. The functions which contains logarithmic terms are called as logarithmic functions. For example, y is equal to log of x plus 1 upon x minus 1. Next example, y is equal to log of x plus 5 to the base 2. Next, exponential functions. The functions containing exponential terms are said to be exponential functions. Exponential means raised to type. Example, y is equal to x raised to x plus e raised to x, or y is equal to log x raised to sin x. Next, transcendental functions. It is the combination of all trigonometric, inverse trigonometric, logarithmic, exponential, etc. are called as transcendental functions. These are generally other than algebraic functions. Example, y is equal to cos of e raised to x plus log x to the base 2. Then, implicit function, a function in which we cannot write the variable completely in terms of x only, and neither we can write x completely in terms of only y. So, this type of function is called as implicit function. Example, x square plus y square plus xy equal to 0. Observe, in this example, we cannot express x in terms of y or y in terms of x. Then, explicit function. It is a function in which we can write the variable y in terms of only x and x in terms of only y. For example, y is equal to x square. Here, y is expressed in terms of x only. And how can we write x? X will be equal to under root of y. So, this is an example of explicit function. Next, parametric function. Here, both the variables x and y are expressed in terms of a third variable. Then this function is called as a parametric function and the third variable is called parameter. Example, x equal to r cos theta, y equal to r sin theta. Now here x and y both are dependent variable, whereas the third variable theta is independent variable and it is called as a parameter. Now an important type, even function. Let y be a function of x. If f of minus x is same as f of x, then the function is called as even function. For example, f of x is equal to cos x, or f of x is equal to x square. Then odd function. Let y be a function of x. If f of minus x is equal to minus f of x, then the function is called as odd function. Example, f of x equal to sin x. We know that sin of minus x is equal to minus sin x. That is, f of minus x is equal to minus f of x. So this is an example of odd function. Next is the periodic function. A function is called periodic if f of x plus t is equal to f of x. Then t is called as a period. Example, f of x equal to sin x. F of x plus 2 pi will be equal to sin of x plus 2 pi, which is equal to sin x, which is equal to f of x. Therefore, sin x has period 2 pi. Now an important type, composite function. Here we have three sets, x, y and z. F is a function from x to y and g is a function from y to z. That is, f maps x from the set x to f of x in the set y, and g maps f of x from the set y to the element g of f of x in the set z. That is, f is function from x to y and g is function from y to z. Then composite of g and f is denoted by g composite f, and it is a function from x to z, and it is given by g composite f of x is equal to g of f of x. Also, we can find f composite g of x, which is equal to f of g of x. Next is the inverse functions. If f is a function from a to b, then its inverse is denoted by f inverse, and it is a function from b to a. Observe that both f and f inverse are inverses of each other. When f and g are inverse of each other, then f of g of x is equal to g of f of x, and that is equal to x. Thank you, students, and happy learning.